All right, so good morning.
Morning, teacher.
Okay, do you hear my
Morning, teacher.
yeah, good morning. All right, so do you hear my voice clearly?
Yes,
Yes.
teacher.
Yes, we hear you,
Yes.
teacher.
Yes, teacher.
All right, that's good. Okay, so we're gonna continue our discussion in electrochemistry. So this time we're gonna proceed to new topic. Okay, so this time we will be applying some introductory lessons in electrochemistry to real life applications. Okay, so how do we where do we apply these things such as oxidation half reactions, reduction half reactions, this oxidation states, etc. All right, so that's the concern of our lesson for today. Okay, so let me share this screen to you. Okay, so do you see this screen?
Yes, teacher.
Yes.
Yes.
All right, that's good. Okay, so today we're going to discuss about this what we call spontaneous and non-spontaneous reactions in electrochemistry. Now remember, when we talk of electrochemistry, we are dealing with electricity and chemical reactions. So there are two things that are the main concerns in electrochemistry. So one of which is this, that electricity is generated by means of a chemical reaction. What does this mean? This means that if there is this chemical reaction, okay, so if there is a chemical reaction, then electricity will be created, electricity will be generated. Okay, so that's the first concern of electrochemistry. Now, the second concern is this: we utilize electricity in order to make a chemical reaction to happen. So what does this mean? There's no chemical reaction this time, okay? But what we will be doing is we will use electricity. So we will employ electricity so that a chemical reaction will happen. So a while ago, there is a chemical reaction, electricity will be created. But this time, electricity will be used, then there will be a chemical reaction. So those are the two concerns of electrochemistry. And one of them, of these concerns, could be spontaneous, and the other one could be non-spontaneous. Okay, so to continue this, let us understand first what the concept of electricity is. Okay, so what is this electricity? So when we talk of electricity, okay, we are referring to, so it refers to the movement of what? Huh?
Charges.
Electrons.
Charges, or to be specific, it's uh,
Electron.
pertaining to the movement of electrons. Okay, so that is correct. Okay, so all right. So we talk of movement of electrons. Okay, so like in let me copy this one. All right, so like in this picture, okay, so we have electrons, and electrons are flowing towards that direction. Okay, and if there is this movement of electron to a certain direction, then there is electricity. So so electricity is related to the movements of electron. Okay, so there must be the flow of electron so that electricity will be generated. Okay, now, an example of that is this picture, okay? So for instance, let's say we are given two substances, okay? So let's say this is our first substance, okay? And we call this substance substance A, okay? And then let's say we have another substance, okay? So let's say the other substance is substance V, or sorry, B, So let's say this is substance B. Okay, so if only like this, nothing happens. Okay, they are slightly apart. Okay, so nothing happens. So, but things will change if, for example, we will be joining them with a certain conductor, for instance. So they are joined by a conductor. Okay, now what do you expect to happen? So this is what will gonna happen if a conductor joins these two substances. One of them will be losing electrons. So one of them will be losing electrons, and the other one will be uh, receiving electrons. Okay, so the other one will receive electrons. Now, for example, it is A who gives off electron, and then B is the one that receives electron. Okay, so the flow of electron will be this. So it's from A to B. All right, now, so if that will be the case, so let's say this naturally happens, okay, so that there is this natural flow of these electrons, okay, whose direction is from A to B, okay, so there is natural flow of this electron. Okay, so natural flow. All right. Then, is there a chemical reaction that happens if electrons just naturally flow from A to B? Is there a chemical reaction that happens?
No.
No chemical
No.
reaction. So there's
Yes.
yes
No.
or no?
No.
So there's no chemical reaction. So what's that thing going on if there is no chemical reaction? A while ago, no conductor, nothing happens. But later on, when we put conductor, it's just naturally that A is giving off electron and naturally that B is receiving electron. Is there a chemical reaction happening? Yes or no?
Yes.
Okay,
Yeah.
yes, there is.
Yes.
There is because as A keeps giving off electron, A is changing. Okay, as B receives electron, B is changing. Okay, and what kind of half reaction happens to A if it keeps giving off electron? What half reaction is taking place to A?
Oxidation.
Okay,
Oxidation.
so it experiences an oxidation reaction. Okay, and what kind of reaction or half reaction takes place with substance B as it keeps receiving electrons?
Reduction. Reduction.
Okay, we call it a reduction half reaction. Okay, now this uh, okay, so this reactions, oxidation or reduction, they just happen on its own. Okay, so things just happen on its own. Okay, so the reaction, uh, wait, the reaction just happen on its own. We don't have any driving force to push this reaction to happen. We don't have such thing as that. It just naturally happen after we connect A and B with a conductor. So if the reaction just happened on its own, where oxidation and reduction takes place, what type of reaction is this in electrochemistry? Okay, please type your answer in our line group. What type of reaction in electrochemistry is this? So the electron naturally flows. There comes oxidation and reduction have reactions where this reaction just happen on its own. So what kind of reaction is this? According to Jessica Wang Shami, it's spontaneous. Wait. I think there is a first. Who's the first one who gave answer? It's Ellie. Okay, according to Ellie, it's a spontaneous reaction. All right, that is correct, Ellie. Okay, so we call this reaction as, all right, so we call this is spontaneous, okay, reaction. All right. So an spontaneous reaction is uh, a chemical reaction, okay, which happens on its own, okay, wherein electricity is generated. Okay. So if there is a natural flow of electrons, there is electricity. Okay, like what I have discussed a while ago. Okay. Now let's. Oh wait. Okay. Let's go back to substances A and B. Now, can you tell me which of the two substances is reducing agent and which one is oxidizing agent? So please type it in our line group. Which of the two substances becomes the oxidizing agent and which one is, okay, from Clara, according to her, A is the reducing agent and B is the oxidizing agent. That is correct. Okay, so B is our oxidizing agent, while A is our reducing agent. All right. Now let's try to apply this in actual setup. Okay. Assuming we have this setup, okay, I will just copy a diagram there. Okay, wait first, huh? Okay, so let's take this as an example.
Wow.
Okay, so let's take this as an example. All right. Now, in this case, I have this setup. Okay. So we have containers with solutions. Okay. One is a solution of zinc sulfate, while the other one is a solution of copper 2 sulfate. Now we have two metal plates here. One is a zinc plate and the other one is a copper plate. Okay. And zinc plate here is containing neutral zinc, okay, atoms, while copper 2 plus contains copper ion, copper 2 to be specific. Okay. Now, with this setup, is there any chemical reaction that takes place with this setup that you see in the screen? Is there any chemical reaction that takes place in here? Yes or no?
Yes.
Yes. Are you
Yes.
sure that there are some changes will happen by just having this setup?
No.
With water, right, teacher?
No. Yeah. We just need them to be in a solution so that uh, okay. I will continue later. Okay, but the question is there a reaction at this point, at this very moment?
No.
Okay, there's no reaction, right? Because none of them is in contact with each other. They are just immersed in a solution, okay? But things will change if the zinc plate will be connected to, so the zinc plate will be connected to the copper plate. So in this case, the two metal plates will have contact with each other. Things will change. And what do you expect to happen? Okay, please type in our line group. What do you think will happen if the two of them will be joined by or will be connected by a conductor, for instance? So Alfred says nothing. Okay, do you have some more suggested answer? Okay, there will be a spontaneous reaction, but can you elaborate it? What is this thing that will happen? Okay, so Jeshlyn already gave us idea that there will be a spontaneous reaction. So what is this specific thing? All right, according to Franklin, there will be flow of electricity from copper to zinc. Okay, thank you, Franklin. All right, I think we are now getting close to what we are expecting. Okay, according to Charles, electrochemistry. According to Jessica, electron is transferred. Okay, and according to Ellie, electron flows from zinc to copper. All right, we have a correct answer from Ellie. Okay, thank you, Ellie. All right, so Ellie said that electron flows from zinc to copper. That is exactly, okay, the thing that will happen here. Okay, so there will be a flow of electron and the direct, oh, wait, somebody is, wait, who's the first? Wait, I'll check. Okay, wait, I will check first. The last message, uh, because the first one, Alfred says nothing, and then oh yeah. Sorry, Ellie. Okay, it's Clara's. Clara is the first one. All right, thank you, Clara. Okay, so it's Clara who first mentioned that there will be flow of electricity from zinc to copper. All right, so the point will be uh, credited to Clara. Okay. All right. So let's continue. So that is true that we expect electron to flow from zinc to copper. Now, why do you think, so this is the follow-up question, why do you think that it will flow from zinc to copper and not copper to zinc? What gives you an idea that, or what makes you think that it will be from zinc to copper? Please explain there in, okay, I think we have some explanation already. Uh, because zinc has more electrons, okay, according to Clara. All right, you can still suggest some more answers. Why do you think that, okay, according to Alfred, because copper is positively charged? Okay, Alfred's answer makes sense. Okay, thank you, Alfred. Because as you can see, copper is a cation. Okay, so it's definitely positive charge. And the one we are allowing to move are electrons, which are negative charge. So we expect negative charge electron and the positive charge copper will attract each other. Did you get a point? Okay, so so what Alfred has mentioned makes sense, though not all the time it works that way. Okay, so there is other reason why uh, the flow of electron is from zinc to copper rather than copper to zinc. Okay, wait, what is that? Okay. But okay, according to Franklin, zinc is negative. But as you can see in our diagram, zinc is a neutral atom here. So it doesn't have charge. But copper, it's a form of ion here. Okay. All right. I think I can give point to another person. Okay, Maxwell mentioned about potentials. All right, one has lower potential and one has higher potential. All right, so I will give credit to Maxwell. All right, this is exactly the reason why copper is pulling the electron and zinc is allowing to give the electron because of their electric potential. And let me introduce this thing. Okay, we call this, all right, so I'll copy this there. All right, so we have the what we call, okay, so we have this thing, okay, we call it the standard reduction potentials. This is the reason why copper is the one pulling the electron and not the zinc. Okay, I have here a table of the reduction potentials of some ions or substances. Now, the substances are arranged according to increasing potential to pull electrons. Okay, what is that? All right, let's continue. All right, now take a look at my list here. Though this is not yet the full version. This is only a portion of that. Okay, this is not yet all the information you need. Okay, to know about reduction potential. So this is only part of it. Now take a look at this. Which substance has the strongest pool of electron? What substance is this? Do you see it?
Fluorine.
Fluorine or
Fluorine.
fluorine. Okay, so fluorine is the one with the strongest pull of electron based on this table only, huh? Not as a whole. Okay, while which one has the lowest or the weakest pull of
Lithium.
electron? Lithium. So if we will be,
Lithium.
for example, if we will be like making fluorine and let's say we will be making fluorine and lithium to be in contact. Okay, so we have here fluorine and we have lithium, okay, for instance. So let's say we will be making them in contact. Now, what do you think will happen if they are in contact? What do you think will happen to their electrons?
The electrons
Fluorine
will
to lithium.
flow
From where?
from lithium to fluorine,
All
is it?
right, that is correct.
Fluorine,
Okay. Is that Erica's voice?
Yes, Erika.
Okay. So that's correct, Erica. That the electrons are expected to move from lithium to fluorine rather than from fluorine to lithium, because according to the table of the reduction potentials of substances, fluorine has a stronger pull of electron rather than lithium. So that will be the direction of the movement of electrons. Okay, and let's correlate this with our given setup a while ago, which is the materials zinc and copper. Okay, now we expect that the electrons will flow from zinc to copper because take a look at the table. Okay, as you can see, this is our copper. Okay, I will mark it so you can easily see, and this is zinc. Now, in the list, which one is placed higher?
copper.
Copper is placed higher because in terms of the reduction potential, copper has a stronger pull of electron compared to zinc. Okay, so therefore, in this setup, if they are connected together by a conductor, we expect that electrons will flow from zinc to copper because copper is pulling it, and things just naturally happen. So there is this natural flow of electron. And if there is natural flow of electron, what kind of reaction is this in electrochemistry? That's
Spontaneous.
Spontaneous.
so we expect that there is this spontaneous reaction, okay? And uh, which of the two metal plates here is considered which one is oxidized or the one that has oxidation? Okay, which one is oxidized?
Zinc.
Zinc is
The
oxidized.
zinc.
Okay, and copper is?
Reduce.
Okay, yes. So
Reducing.
this is oxidized and this one is reduced. Now, by the way, um, zinc and copper, so this one, the metal plates zinc and copper, ay, what happened? Again. So we call them, okay, by the way, we call them electrodes, okay? And there are two types of electrodes, okay? So one, okay, one electrode is, uh, so there are two types of electrode, huh? One electrode is where oxidation happens. So we are referring to zinc in this example. And the other electrode is where reduction happens. So we are referring to copper. So in our line group, please type what electrode is where oxidation happens. Okay, we have a correct answer from Jevent. We call it anode. All right, that is correct. Okay. So we call it anode. How about where where uh, the material is reduced? Okay, what do you call that? Okay, from who's the first? After Jevin. Okay, we have from Jeshlyn. Okay, 11:50. Oh yeah, yeah. So according to Jeshlyn, it is called cathode. Okay. All right. So let's go back. All right. So zinc is where it is oxidized, so we call it the anode, while copper is where it is reduced, so anyway, it is called cathode. All right. So these are the two types of electrodes. Okay. And our what material is our oxidizing agent and what material is our reducing agent? Kindly type in our line group. Which material is oxidizing and which one is reducing? Okay, so who had? Okay, according to Ivana, copper is oxidizing and zinc is reducing. That is correct. Okay, from Ivana. Okay, so let's put it there. Okay, so this is our reducing agent, and this is our oxidizing agent. Okay, and then a while ago, you are confused if there is chemical reaction or not. Okay, now take a look at this. If zinc gives electron, okay, now for every 2 electrons that copper receives, how many electron is given off by zinc? Anybody? Because you see, this is copper 2 plus. So it means for every atom of it, it will receive 2 electrons, right? So how many electrons are given off by zinc for every 1 atom of copper?
Two.
Wait, let's see. Is there someone who... from Clara, according to Clara, 2 electrons. That is correct. Okay. So if zinc gives up 2 electrons, what will happen to zinc? Zinc will become what? Zinc will become... Wait, we have an answer from Erica. What's it? Clara first. So zinc -2 is correct. Okay. So this the zinc when gives off for every 1 atom, huh? Okay, it will give off 2 electrons. So zinc becomes zinc uh, Zn 2 negative or -2. Okay. All right. So is there any change chemically? Is there chemical change in zinc, in the material zinc? Yes,
Yes.
definitely. It
Yes.
changes. Okay. Now,
Yes.
how about copper? If copper receives 2 electrons for every atom of it, what will happen to copper? Can you specify it? Specify it. I'm referring to copper, not just the charge of... Okay, according to... Who's this? According to Clara, the copper will become neutral, no charge. Okay, but I will accept more the term neutral. Okay, so anyway, it's still Clara. All right, so yes, the copper 2 plus becomes neutral copper. Okay, all right, or Nu0. Okay, or just Cu. Okay. All right, so it means there is a chemical reaction that takes place, and we call this reaction as spontaneous reaction. So in a spontaneous reaction, the reaction just takes place naturally, and because of that, electricity is generated. So if electricity is generated, like for instance, let's say I put a load here. So let's say we put this load here. Now, what will happen if we put a load here? What will happen? The load will... Okay, the load will what?
Light up.
Okay, yes. It will consume the energy carried by this electron, which we call electrical energy, and it will be converted to other form of energy. Like for in this case, we have light energy. Okay, so because electricity is generated by this setup, okay, due to spontaneous chemical reaction. All right, so can you give me example of this, the usual thing that we use that has this spontaneous reaction? Can you give me an example? Okay, what example can you give? Light bulb, another example of this material that has a spontaneous reaction. What else can you? We usually use it. We use it all the time, especially especially at home or even in school. Phone, electric circuit, hand phone, another. Okay, we have a correct answer from Alfred. It's battery. Okay, battery is the best example of this setup, and we call that this setup as voltaic cell. Voltaic cell is also known as galvanic cell. Okay, so that's how we call it. Okay, and an example of voltaic cell or galvanic cell is a battery or dry cell. Okay, or this setup as well. All right, so that's for a spontaneous reaction where voltaic cell or galvanic cell is the best example. Okay, so next meeting we will continue with the other one, which is the non-spontaneous reaction. So I'll give you an example of that. Okay, and then we will do some other activities after we finish this spontaneous and non-spontaneous reaction. So do you have any question, guys, regarding this topic?
Teacher,
Okay, yes.
teacher.
Yes, Erica?
Just now you said you will give more examples for the standard reduction potential, yeah? Or we just copy this one?
You can, yeah, there are some others. Some will appear in your
So,
test paper. The other will appear in your other
oh,
activities. I will give it. You will not
oh,
memorize this. You don't need to memorize the table. Okay,
oh, okay,
I
okay.
will be the one to give it to you.
Okay, teacher.
Okay,
Okay,
so are
thank
there some
you.
more questions? No, no question. Okay, so if no more question, anyway, I will share you the screenshot of that. Okay, so let's call it a
Okay,
day.
sure.
Goodbye, class.
Okay, goodbye, sir.
Bye,
Bye-bye,
teacher.
Sure.
teacher. Thank
Bye,
you.
teacher.
You sure?
Okay.
So you.
Teacher.